All right, hello everybody. Let us today continue our series of the theory of everything via ontological mathematics, and we are going to continue with discussing what exactly is net nothing. All right, so remember that this is based upon the philosophical scientific treatise by Mike Hockney. Yes, so what is net nothing? So why nothing? Why do we need net nothing or nothing in the first place? So remember, let's review. Nothing requires no effort to exist. Nothing outside of itself to exist. So that's very important because it halts the infinite regress of always having to appeal to something outside of what exists to explain what exists, right? So when we simply refer to God, well, then the question simply becomes, well, what created God, right? And then if you just say, well, that's just what exists, well, we still want to ask the question, well, why is that just what exists, right? So we want to be able to have an explanation, a closed loop logical explanation, a self-sufficient reason for why existence should exist, right? So if existence is net nothing or equivalent to nothing, nothing requires no effort outside of it to exist. It implies nothing else, no effort to exist. Okay, so nothing outside of itself to exist. So that's why we have nothing. Nothing exists by default. It requires no outside agent to create it, right? So that, stops your infinite regress. It closes your loop. Nothing is the ground state, and it requires no justification. You don't have to justify nothing. It requires no justification. You don't have to posit why nothing should exist. Nothing can prevent nothing from existing, since this would presume something to perform the prevention. You would have to ask, what is it that's preventing nothing from existing? That implies something else already, right? You see that infinite regress there? So nothing can prevent nothing from existing, since this would presume something already existent to perform the prevention, right? So, but here's was the important point. Nothing can exist in two ways. Absolute static nothing, which is pure nothingness with no manifestation. And of course, that's how we usually think of nothing. But mathematics has a trick for us. And via mathematics, and I'll show you the math, not in this episode actually, but in a future episode, we will certainly show you an example of how something can equal nothing. Actually, you know what? I'm going to do it right here. Let me pause. All right, here I'm back. I just did an edit that only took you a second. So nothing can exist in two ways. Absolute static nothing, which is pure nothingness, which is the normal way we think of nothing, pure nothingness with no manifestation. But mathematics has a trick for us, and that you can also have a nothing as a net result of motion, which has internal parts and internal manifest phenomena, but all these parts net to nothing. So an example of how math can do that is, for example, Euler's identity, which is right here, Euler's identity. E to the I pi plus 1 equals 0. Really, I mean, it's as simple as that. You might think, well, that's such a simple equation. Well, yeah, it is such a simple equation. It shows that something very complex, and this is based on Euler's equation, which is actually very, very important, which we'll get in one of the next episodes. I'll talk about just how important Euler's equation is and what Euler's equation does for us. This is called an identity, and it's a special case of an equation that's called Euler's formula. We'll be discussing that in a future video, as I said. So this is a special case of it, a simple case, but it basically shows that e to the I pi plus 1 equals 0. So that shows that there's a lot of things happening here on the left-hand side, but it all nets to nothing. You have the base of the natural logarithm, you have the power to an imaginary number, you have a constant called pi, you have addition, and you have 1, obviously, and then you have 0. And so all these things, all this stuff happening on the left-hand side, quite complex, it all just nets to 0. So that is possible in mathematics, in fact, that you can have a lot of internal phenomena, but they all net to 0. So that's pretty cool. That's pretty nice. That's the trick. That's as simple as the trick is. It's really not that difficult, is it? So here's the principle of sufficient reason. Nothing can prevent any type of nothing. Therefore, all types of nothing exist, right? If there is sufficient reason, that is for the configuration. That's what we're going to talk about next. What is the configuration then of net nothing? What does net nothing actually look like? Okay, so the principle of sufficient reason. Nothing can prevent any type of nothing. Therefore, all types of nothing exist. So that means absolute static nothing, although this is simply inconsequential. But then you also have net nothing, which is consequential because it has internal parts internal phenomena, internal manifestations, but it all nets to nothing. And so that's okay for that to exist too, without requiring any outside agent to create it. Pretty nice, right? So the simplest possible net nothing. The simplest possible net nothing is the perfect circle. An oval, or any other shape, such as an infinite line or a polygon or a sphere as well, would be arbitrarily more complex. So a perfect circle. So a perfect circle is the simplest possible shape. A static circle would reduce to absolute nothing and has no manifestation. So if we're just talking about a single given circle that's not doing anything, it's just sitting there, well, that just results to nothing. It would have no internal manifestation. So the important part is that it is a point moving about a circle with motion. So it's a point which moves about a circle. And this reduces to net nothing over a cycle of the rotation through the circumference. And so why a point moving about the circle? Simply because that's the simplest possible. Why would it be something more arbitrarily complex than a point, right? If we were to say, well, it's not a point, it's just something slightly more complex, well, you would really run into a philosophical logical problem there. You would say, well, how come existence is based on 5 steps up, 5 steps above from the simplest possible? How did it choose 5 steps above the simplest possible? Why is there 5 levels of complexity above the simplest possible level of complexity to create existence from? That'd be totally arbitrary. That is the simplest possible seems just naturally self-justified. So a point moving about a perfect circle is the simplest possible net nothing. So remember, nothing can prevent nothing from existing since it requires nothing to exist. And there is no sufficient reason for why an arbitrarily more complex net nothing should exist. We're going to continue on that point. Why should it be the simplest possible? First, convention. The item of a point moving about a circle, we're going to call a circling. Now it's also going to be a frequency, as we will see later on. So convention, the item of a point, a single point moving about a single circle, is called a circling. Okay, we call it a circling, which is a frequency, as we're going to see. So first of all, now we apply the infinity multiplier to this concept. What is the infinity multiplier? It's from the principle of sufficient reason. So if one circle motion or frequency of net nothing exists effortlessly and is self-existent, then there's no reason why an infinite number of them cannot exist over all possible circle sizes. Thus, an infinite number of them exist over all possible circle sizes in all frequencies, right? Do you see what we're building here? I mean, you should be able to see what we're building here. We're starting with something very, very simple, some very, very simple concepts that are logically justified, logically sound. And we're finding that, wow, we can build something incredibly complex here with pure logic. So we realize that we can justify a net nothing as a point moving about a circle, yes? But then if one of those can exist effortlessly, then any number of them can exist effortlessly over all possible circle sizes, right? So we're getting to something really complex in that. And remember, a circling, what is a circling? I just defined it as a frequency, as we'll see. I'll prove that in a moment. Actually, that might be in a future video. We're just covering the basics here so far. So we're getting all frequencies built up out of the principle of sufficient reason. So another application of the principle of sufficient reason is if one instance of a set of all circlings and frequencies can exist effortlessly, then an infinite number of instances of sets of circlings can exist effortlessly. So you see what we have? We have an infinite number of circlings over all possible frequencies, but we also have an infinite number of instances of each of those, yes? So here's our next convention. Each instance of a set of circlings or frequencies is called a monad, okay? And all of them together, all instances, the entire ensemble of all instances of complete sets of frequencies is called the singularity, which is sometimes referred to as the grand monad or the monad with a capital M. But you should just use singularity just to keep it more clear so that you don't use monad in two different aspects. So each instance of a set of circlings or frequencies is called a monad, and all instances, the entirety of all of them, the whole ensemble, is called the singularity. It all exists inside a singularity. So symbolically, this is how you would symbolically represent it. This is the traditional depiction of the monad. You have a dot in the middle with a circle going around it. Of course, what's implied is that there is motion in the circle, a point going around the circle. I haven't implied that here. Maybe it would have been nice to animate that. But anyway, that's the general idea, is that there is a point moving about this circle, which nets to nothing. Now we're going to get into more detail of this, in the next episode, which is going to be part 3, what is a circling? We're going to see how exactly to define it, how it manifests and what its properties are. And yeah, we'll go from there. We'll get into some really good science then afterwards from there too. So that is what a net nothing is. This seems like it was really quick. Yes, it was. So a net nothing is a point that moves about a perfect circle. And you can have an infinite number of those, and you can have instances of sets of infinite numbers of those. Yes? And so some of you may already know that there's another name for this. So each instance of a set of circlings or frequencies over all possible circle sizes is what that means, is called a monad. So that is actually, I'll just tell you right now because it's pretty fun, that's also called a soul. That's what it is. It's actually what you are and what you're connected to through your brain in some way or another. Yeah, so that's actually a soul, and we're all souls, and that's what we are. We are sets of a mathematical spectrum of circlings or frequencies. That's what a soul is, and we all exist together inside a singularity, because this is all mental after all. And we'll see in a future episode how we go from the mental and the singularity, the unextended singularity and the unextended mind, mental space, to frequency space, a frequency domain, to an extended space-time domain with physical bodies in it and matter. And that's going to be really, really fun. And it happens naturally. We're going to see that it's naturally an extension of what a monad is and what a circling is. The mathematics for it is all built right in. It's really quite cool. So we will get to that next time. Okay? Thank you. Have a good day, whatever you're doing, and take care. Bye-bye.